Uh, Assalamu alaikum. The problem we're going to solving today is a LeetCode problem. The problem number is 993 and the problem name is cousins in binary tree. So as you can see, today I'm going to walk you through the whole process of solving a problem and how I do it. Although I have solved it twice, I tried to record it 2 times, but the sound quality wasn't very good, so I have to do it again. So first of all, you should go through the problem statement. In this problem, it says that you're given a binary tree. In a binary tree, the root node is at depth 0. The children of each depth, children of, and the children of each depth k node are at depth k plus 1. Two nodes of a binary tree are cousins if they have the same depth but different parents. If we are given the root of a binary tree with unique values and the values x and y of two different nodes in a tree. If true, if and only if nodes corresponding to the values x and y, return true if and only if the nodes corresponding to the values x and y are cousins. So this problem, what the problem says is they're going to give you a tree and two values x and y, and you are going to check if they are cousins or not. And the condition for them to be a cousin is that they have to be on the same depth. As you can see, they explain it here. Two nodes are binary cousins if they have the same depth and they have to have different parents. Okay, so these are the condition to be a cousin. So it is a very easy problem. So as you can see, we need to find out what is the depth and the parents. One of the easiest way to do that is and traverse a tree is uh, BFS search, so breadth first search. What breadth first search actually does is it goes through every node on a level or on a depth. It checks every node, and then when all the nodes are visited of that level or of the depth, then it goes to the next depth and traverses through all the other nodes. So BFS is a good choice for this problem. So let's go and find out how to solve this problem. So as I have already explained, we're going to use BFS for this problem. So first let's take a queue, and in the queue initially we will keep the root. And if you're familiar with the BFS, you know that we want an array called visited. So we are going to keep the values of a node that we have already visited. So, and another thing is we need to find out the depth. So we will have a dictionary called depth. We're going to store the depths of every node in this dictionary. So first let's, while queue is not empty, so it means there are elements in the queue, we have to check. Okay, first we have to pop. Okay, so current 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 q dot pop. So what we're doing is uh, we are saving the um, top value of the queue in a variable called current. So this is our current node we are working with. So let's, then we have to check if we have already worked with it with this node before. So and we are going to check if it is visited. That means we have worked with it before. If current dot val. Okay, so if you are wondering where is this val coming from, you can see there is a class written here, and from this we understand that the tree node has three values called Class tree node has three values called value, where the value is stored of that node, and the left child and the right child is stored there. So we are accessing the value of this current node. Okay, we're going to check if the current value is in visited array. If it is in the visited array, that means we have already worked with this node. We don't need to work any further, so we are going to just continue. Okay, I'm very bad at spelling. Okay, if it is not visited, then we are going to say okay, now we are visiting it. So um, we are just appending the value of the current to the visited array. Okay. Oh, another thing we need to do is set the depth of that root node. So as you can see, they have already explained that the root node is a depth of 0, and the children of the depth k node are at depth k plus 1. That means if you are in a depth of uh, 1, then the child nodes are in the depth of 1 plus 1, that means in 2. So from here we can understand that we need to just add 1 to the parent's depth to find out the child's depth. Okay, so root dot val, so the key is the value of that root, and the um, value of the key will be 0. That means we are storing the depth as a value, and it will be 0 because the root node is at the depth 0. And next, what we are going to say is okay, now as it is a tree, it has at most two childs, so it cannot, by it is a binary tree, so it cannot have more than two child nodes. So first we need to check, it might have no child, so it might be a left node. So first we have to check if it has a left child. Current dot, so if it has a left child, then we can simply just append it to the queue, because it is not a visited node. We have never, it might be a node that we never visited. So another thing is, we might not even need a visited node, sorry, we don't need a visited array, because you see, it is a tree, we are not going to traverse, it's not a graph, it's a tree. So there will come no node that we have already visited. Okay, if current, then we are going to just check. Okay, so we are going to append it to the queue plus equal, sorry, current dot left, and now we are going to store the depth. So dpth depth of current dot val. So the key is the value of the child, left child, and the depth will be depth of the current node plus 1. As I have explained before, the child's depth will be parents depth plus 1. Okay, now if the current has a right child, then we are going to append it to the queue again. Okay, and its depth will be dpth will also be depth of the current value plus 1. Okay, plus 1. So now let's check if the depth is actually working correctly or not. We are going to print the depth. Okay, now on the code, see if there is any bug or not. Okay, now let's check. Okay, one has the depth of 0. Oh, and the tree, I think it is this tree. Okay, so as you can see, 2 has 2 is in the depth of 1. Okay, 3 is also in the depth of sorry, this tree. 2 is in the depth 1. 3 has the depth 1. 4 has the depth 1. Okay, the depth is actually correct. So we now another thing we need to check is what are the parents of x and y. So how we are going to do this is we're going to have two variables called y parent and x parent. Initially we are going to assign the value none to them. Okay, now when the current has a left child, we're going to see if the left child's value is equal to x. If it is equal to x, then the current node is a parent, is the parent of x. Also, if the current's value left child's value is equal to y, then it is a parent, it is the parent of y also. So check if the cur current dot left dot value is equal to x, then it is a parent of what? Parent of x. So we're going to say that the current is a parent of x. Again, current dot left dot val equal y. So if the left holds a value that is equal to y, then the current is a parent of y. Okay, we need to do the same for the right child. So current array ght, then we're going to say x parent of current of val. Mm, okay, now let's check if it is working or not. Okay, it shows that. Oh, okay, I understand what I did wrong. It should say right dot val and right dot val. Okay, now it should work fine. 3 and 2. Let's check what was the test case. Okay, 5 and 4. So this was the tree. So 5's parent should be 3. Okay, 3, and 4's parent should be 2. Okay, 2. Okay, it's okay. Now what the problem says, they are cousins if they are on the same depth. So dpth depth of x is equal dpth depth of y, and they do not have the same parent. So x parent. So if the condition holds, then we are going to return true, else we are going to return false. So let's check if it is correct or not. It should be correct. I'm positive. Okay, true. uh, okay, let's submit and check what are the results. Okay, it's a success. So thank you for watching, and it took me a lot of time to record this video. I have to record it twice, as you can see. It's already 2 times accepted, but the sound wasn't very good, and I am also sorry for the background noise. Thank you for watching, and I will provide the problem link and the solution link below in the description. Thank you.